Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we are going to talk about dilation, which is one of the types of transformation. First, these are the objectives of this lesson. Define a dilation. Apply the properties of a dilation. Before we start explaining this lesson, we are going to review this idea, is how to locate a point using a vector. We will talk about this remark after explaining the idea. Example, let AB be a given segment. The question is, in each of the following cases below, locate the point C. First part, AC equal to AB. Here we notice that the only point to be located is C, given that the segment AB is given. As we see here, AC vector equal to AB vector. That means when we see here a positive number, so the vector AB and AC must be of the same sense and of same direction, and the magnitude of AC is twice the magnitude of AB. So by this way we locate the point C. Another example here, AB equal to AC. To locate C, it is better to have the point C to the left side of the equal sign. So we do this step. AB vector equal to AC, then AC vector equal half AB. So do not forget to keep the point that you want to locate it on the left side of the equal sign. Here AC equal half AB, you notice that the sense and the direction of the two vectors AB and AC are the same, but here the magnitude of AC is the half of the magnitude of AB, so you notice that C is the midpoint of AB. Another example, CA equal to CB. Here you notice that C and is found on the left side of the equal sign and on the right side of the equal sign. So try to make this point C is only on the left side of the equal sign. How to do that? Focus on these steps. First, we introduce between the letters C and B a letter A. This way is called Chassis rule, as you remember in the previous years. So CA vector equal to CB. So CA vector equal to CA plus 2AB. Then move 2CA into the left side. You get CA minus 2CA equal, it will be minus CA equal to AB. Finally, minus CA is AC equal to AB. Now we reach to our goal that C is on the left side of the equal sign. You notice that AC here equal to AB, same as example A. The fourth example, BC equal 3AC. Also, you know how to do that. And advice to you is to introduce the letter B here between AC, or the letter A, introduce it between B, C. So apply Chassis rule on the left-sided vector or on the right-sided vector. Here we introduce the letter A between B and C using Chassis rule. So you get BA plus AC equal 3AC. By some calculation you get BA equal to AC. But here you notice that C is still on the right side. Move it to the left side, so AC equal half BA. Try to keep the first letter here A. Also try to keep the first letter here, and this vector is also A. How to do that? You change the order of the letters, so AC it will be minus half AB. When you say AC equal minus half AB, you will get here a negative number. That means the two vectors AC and AB must be of opposite sense but same direction, and the magnitude of AC is half to that of magnitude of AB. So finally, read here the remarks. Now we are going to define dilation. Before we start talk about dilation, here in the first example, we can say that the point C that is located is the dilation of the point B by the ratio 2, and the origin of this dilation is A. To explain that, let us go to the definition of dilation. Let O be a point in the plane and K be a non-zero real number. K is a number and O is a point in the plane. As we see here, the transformation that associates to every point M a point M prime such that OM prime equal KOM is called a dilation with center O and ratio means scale factor K. So if you see this relation OM prime equal KOM, you can say that M prime is the image of M by the transformation that transforms M into M prime. This transformation has two elements, a point O, which is called the center, and ratio K, which is a constant non-zero real number. This number may be negative or positive. As you see here, the example, OM vector and OM prime vector. So M prime is the image of M by the dilation of center O and ratio K. Notation: the dilation with center O and ratio K is denoted by this way of writing HOK. Determination H of M equal M prime. If you see H of M equal M prime, this means OM prime equal KOM. And conversely, if you see OM prime equal KOM, that means H of M equal M prime. The elements of this dilation are two elements, the center O and the ratio K. Here is what we call tips. As you see in the right figure, we have O, the center, we have a small triangle ABC, we have a large triangle A prime, B prime, C prime. Here H of A equal A prime, H of B equal B prime, H of C is C prime. So A prime, B prime, C prime are the images of A, B, and C respectively by the dilation H. So the image of the triangle ABC by the dilation H is A prime, B prime, C prime. So H of ABC equal A prime, B prime, C prime. Now, before we start by this example, remember these ideas. Example, let ABCD be a direct rectangle such that AB equals 6 and AD equal 2. I is a point such that AI vector equal 1 over 3 AB. As you see here in the grid to the right side. Here, let H1 be the dilation with center A and ratio 3. So K here is 3 and the center is A. And H2 is another dilation of center I and ratio minus half. First part, verify that H1 of I equal B and determine H1 of D. Now, how to verify that H of I equal B? To verify that, we must remember that what are the center and the ratio of H1. H1 is of center A and ratio 3. So when we say that H1 of I equal B, that means AB equal 3I. Look to the figure to the right side. It's clear that AB vector is equal 3I vector because they are of same sense, same direction, and the magnitude of AB is 3 times the magnitude of AI. So AB equal 3AI, thus H1 of I equal B. Now, how to find the image of D by H1? So you must search for a point such that AD prime equal 3AD. If we look to the figure to the right, we see that AE vector is equal 3AD vector. So we write AE vector equal 3AD. So we can deduce that H1 of D equal E. The second part, determine now H2 of B and H2 of I. Before we start by this part, we must remember what are the elements of H2. The elements of H2 are of center I and ratio minus half. To find H2 of B, you must search for a point such that IB prime equal minus half IB. So again, look to the figure to the right side. You must find a vector which is of opposite sense of IB vector, but of same direction of IB and of magnitude which is half of that of the magnitude of IB. We note that IA vector has this property. So we write IA vector equal minus half AB. So we can write H2 of B is A. Try to think how to find H2 now of I. Yes, H2 of I is I. Why? Because you must find a point I prime such that II prime equal minus half II. But II vector is 0 vector. So I prime is 0 vector because I prime equal minus half times 0 vector. So you can say that I prime is 0 vector, so I prime is I. And we can notice that the dilation of the center of the dilation is itself. Now the third part. Find the dilation H3 with center D that maps A into D. Here in the third dilation H3, the unknown element is K because the center is given. But we can use this dilation that transforms A into E, we can use this idea to find the ratio. It means that H3 of A equal E. That means, yes, as you said, dE vector equal KdA. Let us see the figure to the right again. This is the vector dE, and this is the vector dA. As you notice that they are of opposite sense. So first, K here will be negative. Also, the magnitude of dE vector is twice the magnitude of dA vector. So that means K must be equal -2. Thus, we found the second element of H3, which is the ratio K -2. Now application. Let ABCD be a direct square with center O. I, J, K are the midpoints of the segments AB, BC, and OC. As you see the figure to the right, given the dilation H with center B and ratio 2, another dilation H with center O and ratio -12, and we have also a rotation with center B and angle pi/2. First, determine the image of the square BJOI by the dilation H. Please try to stop the video and try to solve this question carefully before you see the solution. How to find the image of square by dilation? First, you must find the images of the vertices of this square. Now we will start. H is of center B and ratio 2. Because B is the center of this dilation, so it is easy to say that H of B is B. Now, H of J is C. Why? Because BJ and BC vector, we notice that these two vectors of same sense, same direction, and the magnitude of BC is twice of the magnitude of BJ, so BC vector equal to BJ. So that means H of J equals C. Also, H of O equal D for the same reason, and finally H of I equal A, as you see. So we found all the images of the four vertices of the square BJOI. The second part, determine H of A. Here, capital H is the notation of the second dilation of center O and ratio -12. To find H of A, you must first search for a point A prime such that OA prime equal -12 OA. This is the vector OA. You must find a vector which is of opposite sense of OA and of same direction of OA, and the magnitude of this vector OA prime equal half of the magnitude of OA. This vector will be OL. So L will be the image of A by the second dilation H. Try to think before showing the solution. Finally, the third part, determine H round R of J. These are the composite of transformations. How to solve this? Pause the video for a while and try to solve this part. How to solve it? H round R of J equal H of R of J. First, you must find the image of J by the rotation of center O and angle pi/2. R of J is I, and H of I is A, and it is solved in the first part. So H of A will be finally L because it is solved in the second part.